To fully understand how we need to teach the functions to our 9th grade students, 8th grade students, we really need to take a look at what they need to understand by looking at the assessments. So I gathered up a bunch of assessment examples from all different sources to help us take a look. So I asked everybody during the webinar, what assessments are you giving? And we got such an array of answers here. I loved getting all the answers, and I will be adding some assessment examples to my future documents based on what you said. So we had some people from New York, the New York Regents. We also had Common Core and Park, of course, and then less and less of those as more states are getting, I don't know what the right word is there for, frustrated or pulling out or altering what they're doing. We also had people chime in from Florida and North Carolina, so we will be adding some of these as well. So let's take a look. The first example I wanted to talk about was this Park, from the Park Practice Test for Algebra 1, and this one talks about the cost to manufacture X pairs of sunglasses can be represented by a function C of X. If it costs $398 to manufacture 4 pairs of sunglasses, which of the following is true? Select the correct equation. And so this one is a basic understanding of function notation and what a function is. And just a quick note here, at the bottom, there's a link to these actual assessment examples, and I have created for you a PDF of all these slides, so at the end you will have all these links as well. Otherwise, if you're getting a little itchy, you can always take a look at these bit.lys right down here at the bottom. So this is one example of what they need to know. As we look at the next one, this one is from Smarter Balance Practice Test, and this one is asking them to compare two functions. So the Smarter Balance tests are given at the 11th grade level, so although this is a sine or cosine type function, they would still want the students to be able to compare them. So we talk about g of x, and we also talk about f of x being two separate ones, and they want them to use the add point tool to add a point that will satisfy each given condition. So a point on the graph where on the graph of g where x equals 0. So they want them to understand that right here at this point, and so they would be able to put a point, drag a point right there using this button. So a point on the graph of g where f of x is greater than g of x. So a point on g where f of x is higher. So we could choose something like here or down here. All of those would work. And then a point on the graph of f where f of x equals 0. So here's f of x. When is the y equal to 0? So we've got quite a few correct answers here. Smarter Balance will mark it correct as long as there's one. If you'd like to see the more formal answer keys, feel free to follow these links. I do have the link with the answer key for you. The next one is from Park, a Park Practice Test. And so Jerome is constructing a table of values that satisfies the definition of the function. And so they really need to understand that every input has exactly one output. And I like showing these examples to my students as well, because it says select all that apply, and our students are so used to going down and choosing just one. They said when they did do the practice tests for these and the initial couple tests that a lot of students were finding the first correct answer and stopping. And so this was something that they were getting incorrect. So I believe that looking at some of our examples in the very beginning will really help our students to solidify this, and then careful reading, which for some of my students, that's really tricky for them. They like to fall back to what they're used to. Another one of the Park Practice Tests wants them to understand the domain and range. And so at this point, we're starting to see the variety of questions that they really expect them to know. And so a local theater sells admission tickets for $9 on Thursday nights. At capacity, the theater holds 100 customers. So the function m of n equals 9 times n represents the amount of money the theater takes on Thursday nights, where n is the number of customers. What is the domain of m of n in this context? So they really need to understand that domain is that input, and so that they need to be non-negative, because obviously we can't have negative people, and they need to be less than or equal to 100. And so understanding all of these things about domain, this is what we're going to discuss today, as well as the previous examples. Here's one from the New York Regents exam. This is given from the example from August 2015. And if you go back to this link here, there are lots and lots of sample problems in these, which I really appreciate. You can go back to a lot of different dates, but I found this one, which was great for our example today. Which representations are functions? So they give them a table, a graph, a set of numbers, and an equation, and they need to be able to tell which one is a function. So this one is not a function, this one is not a function, but 2 is a function and 4 is a function. And so allowing students to be able to see it in 4 different representations, really important for them to practice that. And I'll show you later in one of the future sections how to help them connect that and give you a handout that you can use with your class tomorrow. This one also came from the New York Regents exam, and this is talking about evaluating functions. So my students would automatically, if they did not have a lot of practice with this, they'd automatically see the fraction and be frustrated. And so I don't know if you could relate, but I would really give them a lot of practice where these are going to cancel out, give them nice even numbers. The next one comes from Smarter Balance Practice Test. This one is talking about the height of a plant in centimeters is modeled as a function of time in days, and it tells them to consider the graph of the function. Enter the average rate of change for the height of the plant measured in centimeters per day between day 0 and day 20. And so this is the type of question that I have in our slope unit where they have to write linear equations. I believe it's unit 3. So even though this isn't where we initially introduced functions in my website, in unit 1, we are going to be using these functions all the way through our course. And so it's really important that they get that solid foundation. And here's another one that will be in unit 10 or 12 is where quadratics are discussed in my setup. And so this is from the Park Practice Test. The figure shows a graph of the functions of f of x in the xy coordinate plane with the vertex at 1, 9 and the zeros at -2 and 4. Then it goes ahead and gives them a completely different function down below. The function g is defined by g of x equals -3x plus 2. Which statements are true? Select all that apply. For a lot, some feedback on this question, a lot of teachers said that their students were so caught up in all of this information that they completely missed this information. So this might be something where you might model that they graph it to be able to answer these questions. And one last one, Smarter Balance Practice Test, where we need to take a recursive form where f of 1 equals -3, and then f of n equals 3f of n minus 1. So 3 times that function of the one before, where n is greater than or equal to 2. And so a lot of students have a lot of trouble with this. This is something we hit pretty heavy on in our Algebra 1 course through Algebra 1 teachers. So this gives us quite a variety of examples that we're going to need to look at.